We're now going to talk about electrochemical principles. We're going to build tiny galvanic cells using filter paper and a few drops of solutions. The reason that we're doing it on this small scale is to be more green and environmentally friendly by reducing the amount of waste that is produced. So we are going to, in a galvanic cell, just like in a galvanic cell, we need to add a salt bridge in the middle to allow our ions to flow. Okay. We're going to add a copper solution to the copper side of our galvanic cell. And we're going to add zinc solution to the zinc side of our galvanic cell. Our salt bridge solution that I already added is ammonium nitrate. Alright, for our galvanic cell, the red lead goes on the cathode and the black lead goes on the anode. And it will give us a positive reading when our anode is on using the black lead and our cathode is using the red lead. So you want to record the voltage for this cell. We're now going to try zinc versus magnesium. Okay, we're going to add our salt bridge to the center. We're going to put our zinc solution on our zinc side. We're going to add magnesium solution to the magnesium side. Now the magnesium oxidizes pretty readily, so I've had to sand down the magnesium so that it makes good contact. And so you want to record the voltage for this cell. Alright, we're now trying zinc versus tin. And you may have noticed that our voltages jump around a little bit. That is, has to do with when we make a good connection or not. So what you want to record is the one that you see most frequently. Okay, so we're going to add zinc to the zinc side of our cell, zinc solution, and tin to the tin side of our cell. Right. Start with the red lead on the zinc and see what we end up with. Oh, we have a negative value, so we're going to swap the leads around. Put the black on the tin and the red, black on the zinc, red on the tin. There we go, that's better. And you want to record your voltage. We're now going to try copper versus aluminum. So we add our copper solution to copper side. We're going to add aluminum solution to the aluminum side. Now when you're balancing these chemical reactions, make sure you remember what charges your metals have and that you have to balance the amount of electrons or the amount of charge as well as the ions. So I'm going to start with red on the copper side, black on the aluminum side. All right. And you want to record your voltage. All right, we're going to also do copper versus iron. Add copper to the copper side. And iron to the iron side. Start with the red lead on the copper and the black lead on the iron. Record your value. All right, now in all of these cells, we're going to assume that copper has zero reduction potential. Now that is not entirely the case. We usually use a standard hydrogen electrode, but those are much less safe to be using in the lab because it requires bubbling hydrogen gas. So we're going to assume copper is zero and determine the reduction potentials for all of the other metals that you have seen. You are going to use the reduction potentials that we just, that you're going to calculate from the reactions that we've done, from the galvanic cells that we've done, in order to calculate what voltage you would read using aluminum and magnesium. So you're going to do a theoretical calculation based on the reduction potentials that you calculate. We're now going to determine what happens when concentration becomes a factor. So we're going to make a galvanic cell using our salt bridge in the middle, and we're going to do copper versus copper. So I'm going to put 4 drops of our copper solution next to each one of our electrodes. And we are going to measure the voltage that we see. Okay. So all right, so you notice we're pretty close to zero. Our concentrations are equal. We're going to now adjust the concentration on the right side of our cell by adding 4 drops of ammonium hydroxide. This forms a complex with the copper, not allowing it to be available. And so we are going to now measure our voltage. And you want to use the voltage that you initially saw for the voltage of this cell. So you can see that when our concentration changes, our voltage also changes. And you'll be able to calculate the formation of that complex, the equilibrium constant for that, using this voltage. We are only going to be doing part 1 and part 2 of this experiment. We are not going to do the titration portion of this experiment. If you need additional help with calculations, there is a math help sheet available for you on Canvas.